Hi everyone, in this video we're going to go through an example finally of a function that's represented by words. So we are given the notation here. We know that b equals n of t is our function. So we're inputting t's, we're outputting b's, and the function name is n. And this represents the number of birds in thousands migrating through Washington T years after 1990. So we output birds, and that's thousands, and we input years after 1990. Okay, so this is what our function n does. So first we're given a statement with some values actually in the function notation, and we're supposed to explain its meaning using everyday language. So in the context of this problem, n is the name of the function, and we know that function n inputs years after 1990. So this is years, and it outputs the number of birds in thousands. So we're going to say 7 years after 1990, which is in 1997. 9.2 thousand birds migrated through Washington. 9.2 thousand I would not say is everyday language, so I would take the extra step, please, to convert that to something that's a little bit more normal. We do absolutely say 9.2 million, but 9.2 thousand, not generally a thing. So I would say 9,200 birds migrated, that sounds funny, but I think that's right, through Washington. So generally going for a complete sentence, make sure you include all numerical values, so the 7 and the 9.2, include units, which in this case meant converting the 7 to 1997 and the 9.2 to 9,200 birds. So make sure that you get those in a way that makes sense and watch for anything weird like the thousands. In part B, we're told that n of 9 is equal to 6.1, and we're asked to find the average rate of change from t equals 7 to t equals 9. So if we know, what was it, n of 7 is equal to 9.2, and n of 9 is equal to 6.1. So we want to take n of the final value minus n of the initial value and divide by the final value minus the initial value. And n of 9 is 6.1, so we can just straight up replace these. N of 7 is 9.2. 9 minus 7 is 2, and it looks like we're going to get a negative number on top, 6.1, 7.1, 8.1, 9.1. So it looks like 3.1 is the difference between them. And since we're subtracting the larger number, that's going to be negative. So 3.1 over 2, or we could go ahead and go one step further, 1.55. Okay, so that's what I'm getting. And again, I like to go down to that, divided it. So it does have a denominator 1, but I still generally write that denominator just so that I will remember that there is more than one number to interpret in that statement. I love to draw myself axes just to kind of have a visual on what goes where in these problems when I'm doing average rate of change in particular. So this is years since 1990. And this is birds in thousands. Okay, so when I calculate a slope, it's going to be the change in the number of birds over the change in the time. So this is 1,000 birds, and this is years since 1990, but I don't know that that'll matter when we get down into it. So again, with average rate of change, we want to specify the interval that we're looking at. So I would say, here, we'll give that a capital, between 1997 and 1999, the number of birds migrating through Washington is actually negative, so it's decreasing by 1.55 thousand. So again, I would combine that and make it 1,550 every 1 year. Number of birds migrating through Washington is decreasing by 1,550 birds per year on average. So again, really important things when you're interpreting average rate of change, capture the interval, make sure that you capture both the numerator and the denominator. Sometimes the denominator is a 1, so it gets sort of hidden, but it's in there. And make sure you capture the units of the numerator and denominator. And I think it is important to mention that this is on average. This is not something that we expect to be perfect or exact for each year in there, but if we average out what happened over the 2 years, that's what we're seeing. All right, thanks for watching.